Hi, and welcome to day 7 of Rational Expressions. Today we are solving rational equations. And you can see I've already listed the steps to try to make the video a little shorter. The first step is to factor any denominators. The second step is to find your LCD. The third step is to multiply each term by the LCD and to get rid of the denominator. 4, solve the resulting equation. And 5, check. That's your most favorite thing to do, I know. So for the first problem, I have to solve the following equations for x and give evidence that your solutions are correct. That's your checking. So for number 1, x over 2 plus 1 over 3 equals 5 over 6. So my LCD is going to be 6 because smallest number that 2, 3, and 6 go into is 6. So I'm going to multiply every term by 6. Here I multiply by 6. 2 cancels out 6 and it becomes a 3. So then I'm left with 3x. Here when I multiply by 6, the 3 cancels with 6, I'm left with a 2. So then it becomes plus 2. Here the 6 is just canceled, so I'm left with 5. So my equation is 3x plus 2 equals 5. So I'll subtract 2 from both sides. 3x equals 3. Divide both sides by 3. X equals 1. And then for a check, I just substitute 1 everywhere I see an x. So it's 1/2 plus 1/3 equals 5/6. What we've been talking about is you have to have a common denominator in order to build fractions. So if my common denominator is 6, 1/2 is equal to 3/6. 1/3 is 2/6 is equal to 5/6. So 2/3 plus 3/6 plus 2/6 is equal to 5/6. So I need to show, get all the way down to the last step to show that one side equals the other. So that means my answer of x equals 1 is correct. When you're doing a check, just an FYI, you cannot cross the equal sign. You work on one side, then you work on the other to try to get one side to equal the other. So for number 2, I already have an LCD of 9. So I can multiply everything by 9, or when all my denominators are the same, I can just cross them out and then just solve. 2x plus 5 equals 8. So subtract 5. So 2x equals 3. 5 by 2. My answer is 3/2. Now that seems kind of strange to get a fraction when we're solving fractions, but it can happen. So for the check, in place of x, I'm going to put 3/2. So here, when I multiply, that's just a 2 over 1. So my 2's cancel out. So I have 3/9 plus the 5/9 equals the 8/9. And 3 plus 5 is 8. So 8/9 equals 8/9. Number 1, I need to find an LCD. And in this case, my LCD is 12. I'll multiply one side by 12, multiply the other side by 12. Here the 12's cancel out, and I just have x plus 3. Here the 6 and the 12 cancel out, and with the 2. So it's equal to 10. So x equals 7. So then I need to check. Make sure everything works out okay. 7 plus 3 over 12 is equal to 5 over 6. Well, 7 plus 3 is 10 over 12 equals 5 over 6, and you can see that that reduces to 5/6. So that works. All right, for number 3, this is kind of going into some of these LCDs that you didn't like. The process for LCDs is the same all the time. So for this one, my LCD is 1 over everything you see is by the x, and x minus 2. So I multiply everything by x minus 2. So here the x's cancel out, and I'm left with 3 times x minus 2. Here the x minus 2 goes, we're left with 8 times x, or 8x. So I have 3x minus 6 equals 8x. So negative 6 equals, and I subtract 3x, 5x. Divided by 5. So negative 6/5 is equal to x. Yuck. That looks pretty ugly to check. But if you notice in the directions, it doesn't say to check. So we're okay. I know it doesn't seem like a fraction in your answer, but it's okay. For number 4, solve the following equation for A. My LCD here, we're looking at everything. It's going to be A plus 2, A minus 2, because that's what this denominator factor is. It's A plus 2, A minus 2. So I have to have 1 of everything I see. So A plus 2, A minus 2. A plus 2, A minus 2. And last one, A plus 2, A minus 2. So my first fraction, this A plus 2 cancels out with that A plus 2, so I'm left with 1 times A minus 2. The second fraction, the A minus 2's go, and I just have plus 1 times A plus 2, so plus A plus 2. Here, everything goes, so it's equal to 4. So here I have 2A equals, my 2's cancel out, 4. So A equals 2. Now, I know that this one doesn't say to check, but we're going to check this one anyway. And when I check, I'll get 1 over 2 plus 2 plus 1 over 2 minus 2 equals 4 over, if I square 2, I'll get 4 minus 4. So I get 1/4 plus 1 over 0 equals 1 over 0. You can't have zeros in the denominator. Therefore, since this was my only solution, we have to reject it. And my 3 little dots mean therefore. There is no solution. This is what we call extraneous roots. What that means is when you're solving, you get an answer, but when you check, your answer makes the denominator undefined. So you have what they call extraneous roots. If you look at the word extraneous, it has the word extra in it. So essentially what you're getting is extra roots. So that's something that we have to be conscious of when we're solving these. So for number 5, and to solve the following equation, remember to check for extraneous solutions. So my LCD is 12x because I have the 3 and the 4, and then I have the x, and the LCD between 3 and 4 is 12, and then I only have x to the first power, so multiply everything by 12x. So in the first fraction, the whole thing cancels and you're left with a 4, so 4 times 4 is 16. Plus, in my second fraction, just the 4 cancels with the 12 and you get a 3. So I'm going to have 3 times 5x, so plus 15x. And then in the last fraction, just the x's cancel, so it's 3 times 12, which is 36. So I'm going to subtract 16, so 15x equals 20. Divide by 15, so x equals 20/15ths. And I'm going to reduce that. 5 goes into both of them. Sorry. 5 goes into both of them, so I have x equals 4/3. This one we need to check. 4/3 times 4/3 plus 5/4 equals 3/4/3. Here, those cancel, so I have 4/4 plus 5/4 equals, this is like saying 3/1, and then we multiply by the reciprocal, times 3/4, it's the state change flip. So I get 9/4 on the left equals 9/4 on the right. Therefore, it works. Yay! Alright, next page. Solve the following equation. Remember to check for extraneous solutions. So looking at my denominators, I see that this factors to b plus 3, b minus 3. So my LCD, in this case, is going to be b plus 3, b minus 3. So you need to multiply each term by b plus 3, b minus 3. I know it seems very redundant to keep writing this stuff out, but it's the way to make the least amount of mistakes. So in my first fraction, the b plus 3's go, and I'm left with 7 times b minus 3. My second fraction, the b minus 3's go, so I'm left with plus 5 times b plus 3. And in my last one, everything goes, so I'm just left with 10b minus 2. So I need to distribute 7b minus 21 plus, distribute again, 5b plus 15 equals 10b minus 2. So 7b and 5b is 12b, negative 21 and 15 is negative 6 equals 10b minus 2. So subtract 10b from both sides, you get 2b minus 6 equals negative 2. Add 6 to both sides, so 2b equals 4. Divide by 2, so b equals 2. Oh, what fun. I don't think that 2 should make this denominator 0, but we will check. 7/2 plus 3 plus 5/2 minus 3 equals 10 times 2 minus 2 over 4 minus 9. So I will get 7/5. And this is going to be minus because that denominator is going to be negative, so it's going to be minus 5/1 equals 10 times 2 is 20, minus 2 is 18, over 4 minus 9 is negative 5. So my common denominator has to be 5. So I need to multiply this by 5 and this by 5. So we'll have 7 minus 25 over 5 equals a negative 18/5. I'm just putting the negative out in front of the fraction. 7 minus 25 is negative 18. Oh, and aren't we lucky there? That one worked out. All right, here we go. We're in the home stretch. This is the last one we have to do. So we have x squared minus 8x plus 12, and that's going to factor to x minus 6 and x minus 2, which is good because that's what I see. So my LCD, I'm just kind of moving it out of the way over here, is x minus 6 and then x minus 2. So x minus 6, x minus 2, x minus 6, x minus 2, and the last one, x minus 6, x minus 2. So in the first fraction, the x minus 6's go, and I just have a 1 out in front, so it's x minus 2. My second fraction, the x minus 2's go, but I still have an x in that numerator, so plus x times x minus 6. Everything goes, the last one, so equals 4. All right, so let's get to work here. I have x minus 2 that I need to distribute, plus x squared minus 6x equals 4. So I combine my like terms, write in descending order, I have x squared minus 5x minus 2 equals 4. Since I have the x squared term, I need to get this equal to 0, so I'm going to subtract 4. So I have x squared minus 5x minus 6 equals 0. So if I add them, I will have x minus 6 and x plus 4. So I have x equals 6 and x equals negative 1. So let's go back to the original and check. I have two answers, and I will answer checks. So 1 over 6 minus 6 plus 6 over 6 minus 2 equals 4 over 36 minus 48 plus 12. And 1 over 0 plus 6 over 4 equals 4 over 0. Remember, I can't have those zeros in the denominator, which means I can't have 6. So I need to reject that. And then I just got to check to see if negative 1 will indeed work. So, check number 2. 1 over negative 1 minus 6 plus negative 1 over negative 1 minus 2 equals 4 over, when I put in negative 1, I will have 1, and then it becomes a plus 8 plus 12. So I have 1 over negative 7. I'm going to have plus a negative 1 over a negative 3 equals 4 over 21. So I have negative 1/7. I'm just going to make the whole fraction negative. And here I have two negatives, so it becomes plus 1/3 equals 4/21. My LCD is 21, so I need to multiply the top and the bottom in the first fraction by 3. So I have negative 3 over 21. Multiply top and bottom here by 7. So plus 7 over 21 equals 4 over 21. So negative 3 plus 7 is 4 over 21 equals 4 over 21. So indeed it does work. Yay! All right, that is solving rational expressions. Kind of quick, but I think you'll get the idea. Make sure you can notice the difference between what we're doing with the LCDs with complex fractions versus adding and subtracting versus solving.